Good morning, everyone. I'm sorry I have to cancel today's class because something wrong with Zoom, so I cannot start the Zoom meeting in the morning. So instead, I'm gonna post a short video. Stephens, I assume all of you have finished watching the Stephens videos. I posted on Canvas, and so I'm just gonna add some comments in this video. So the first slide is about the triangle. Make sure you are very familiar with what are the sine, cosine, tangent, secant, cosecant, and cotangent. So sine just the O over H. So make sure you are very familiar with these 6 ones. And the corresponding secant is just the 1 over sine. So one way to remember it is just you can see if the first letter for the secant, cosecant, it is S, then the other one in the denominator is S. So you can see the second one is S. Then denominator is C. It's kind of a balance. So in this example, it's trivial for a right triangle. If all the 3, 4, and 5 are given, so we for any theta and alpha, we can find the corresponding 6 numbers in this way. So you can see, just the 1 over 4 over 5 is this one, and similar. Okay, so this is a very important unit circle. You have to, this is not difficult to memorize if you understand what this one is talking about. So first, I'm gonna talk a little bit more about this one. So you can see in this circle, it's just a circle, of course, it's a pi. So you can see this is the 0 normally, or 360, because they're the same thing. So you can see this one is 180 degree, or in other words, it is just a pi. 0, pi, then another direction, 2 pi. Okay, so first let's try to use this one to see what it means for this specific triangle. So you can see from here, it is 30 degree. So that means this angle is 30 degree. In other words, it is just a pi over 6. Okay, so we are going to use this triangle. So you can see in this triangle, for this part, because it is in the circle, it's a radius of the circle, we know this is a unit circle. So this part is just 1. This blue line is just 1. Similar, for any other lines in this circle, it's just 1. Okay, so we know this one, and this angle is 30 degree, which means pi over 6. So we know, let's write down we know this is the 1. And based on this coordinate, we know this part is the first one, that is square root of 3 over 2. And the y value, this is the y value, which is 1/2. So we know it is 1/2. Then the question is actually last one. We know this one, and this one, so we know the corresponding 6 numbers. Then similar, in this unit circle, everything here is 1. Then we know this value and this value from this coordinate. So all the 3 numbers are given. That means, okay, now we can get sine of 30 degree or sine of pi over 6. And the cosine, tangent, secant, cosecant, cotangent from this one. This is how we're going to use that one. But you can see for this part, all the numbers are positive. But in this part, then let's try another triangle. Let's try this triangle and see what happens. Again, because this is the radius of a unit circle, so this is also 1. This is always 1. And then let's see this part. This is positive because the value here is just the value here. You can see it is positive. And this value is actually the y value. That is just 1/2. It's the same. But pay attention to this one. This is negative because it's in this part. So it is negative. So you can also tell it from here. So this time, this number is negative square root of 3 over 2. So you can see the difference of the 2 triangles, even though they look pretty similar to each other. But pay attention to this value. the black triangle is negative, but the red triangle, this part is positive, so that you can see. All right, so an exercise is, okay, first list the sine, cosine, tangent, cotangent, blah, 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 the 6 numbers of this triangle, and then list another 6 numbers of this triangle, so you can see which one is the same, which one is the different. Of course, you can see sine of this, but pay attention to, for this one, the red triangle, it is sine 30 degree, but for this triangle, you have to say sine. We know this is 30 degree, but we are looking for the value of the angle right here. So this blue angle is 150 degree. So you have to say, for the black triangle, is sine 150 degree. That is sine is this part divided by this part. You can see both of them are positive, so the value is the same as this one. But for the cosine 150 degree, you can see they are different, because cosine of this part is this one divided by 1. This one is negative, so the cosine should be negative, which is the even though this one and this one, they have the same absolute value, but the sign is different. This is negative, this is positive. So you can see that if you use this unit circle, actually we can get most of the number. For example, what is the sine 30 degree? Excuse me, sine 300 degree, or sine 3 pi over 2. So for example, let's try one more example. You can see if the question is, what is sine 240 degree? So that means we have to use this triangle. In this blue triangle, the radius is 1, so this is 1. But this one, you can see this part is negative. This part is not also negative. So we know the sine is negative, and the cosine value is also negative. So pay attention. Later, I'm gonna post a unit circle of just this circle. So you have to fill in the blank. What are they? This is a good exercise. And later, okay. So this is the first method. If the question asks you, try to solve for this equation or find the inverse function. Another method is to just draw the function graph. So for example, for the sine of x, we know it is like, this is excuse me. Sine of x is a periodic function. Later, I'm going to go back to this function graph to see how can we use it to solve some specific functions. Okay. And you can see, okay, this is the second kind of question. If we are given sine of theta is 3 over 5, then the question asks you what is the corresponding cosine and a tangent. Pay attention to the range of theta, that is from pi over 2 to pi. So in this one, sine theta, so this is theta, 3 over 5. So we know this one must be 4, because it is a right triangle. So please pay attention to the cosine of theta. So cosine of theta based on this triangle is just this line divided by this line, so which is 4 over 5. But please pay attention to the theta. Theta is from pi over 2 to pi. So that is from pi over 2. This is pi over 2 to pi. This is pi. So we know the triangle is in this part. So you can see that if the triangle is in this part, then the corresponding this value is negative. This value divided by a positive number is negative. So that's how we got negative 4 over 5, not positive. And then this is a very important equation. Sine theta plus cosine theta is 1. And then the periodic, remember a periodic function is never one-to-one function. First, it is easy to tell from the function graph. For the sine of x, you can see this is the function graph. So that means if you try to draw a horizontal line, you can see we have a lot of intersections. So this is never a one-to-one function. And then the second method is you can just tell it from here. So we know a function is 1-to-1. That means f of x is f of y. We know x is y. But because it is a periodic, this is a method number 2. By function equation, by math, the method number 1 is horizontal line test to determine whether a function is 1-to-1. So you can tell from here, because it is a periodic function, so we have this one, but x plus p is now equal to x. So this is a contradiction. So this is the second method to show the function is not 1-to-1. And then for the sign of x, the domain means the home for x, and the range means f of x. So domain is all the real numbers, but the range is just from -1 to +1. Pay attention to the parentheses. This is the parentheses means the function value 1 can be achieved. If it is this is bracket. And the period is just 2 pi, similar for cosine theta. Tangent is a little bit different. Tangent function has a vertical asymptote. If you try to draw the function graph of the tangent line of the tangent theta, it's like this one. So you can see here, this one we have a vertical asymptote. And this one is pi over 2. So the vertical asymptote is this line. And the next one, range and domain for the 3 functions. Example. This example in Stephen's video is pretty straightforward. It's very clear, so I'm not gonna make a lot of comments here. Okay, so here, okay, right. Then this one on the interval is from 0 to 2 pi. So for this question, we have many solutions. We have 5 solutions in total, not just the one solution. Because from this equation, you can see we have 2 subcases. The first case is this tangent of x is just 0. The second subcase is this term is 0. So this is the first case, and the second case, tangent x is 1. So for the first term, you can see, okay, this is where we are going to use the function graph. So this is how can we use the second method, the function graph, to get the corresponding x value. The first method is to use the unit circle. I'm not going to talk about it because Stephen's video, he used that one. And I'm going to talk a little bit about the second method. Sometimes it is easier for you to tell how many solutions do we have for this kind of question by using the function graph. So for example, this one, for the first case, we know this is a tangent function. So for tangent function, you can see negative pi over 2. This is the tangent function. It's also periodic because you can see it's repeated for infinite many times. So, but pay attention because the domain is from 0 to 2 pi. So domain is from 0 to 2 pi. The question is, what is the solution when tangent of x is 0? So for the function graph, you can see if we draw a line, horizontal line, then the intersection is a solution. So we have number 1 solution, number 2 solution, number 3 we don't have the solution because if you finish the function graph, it is like this part. This is a oh, excuse me. Oh my gosh. Okay. It's no. God. Yeah, got it. This is another horizontal line, which is this is 2 pi. So actually, we only use this part. We don't care about this part because it is out of range. So if we try to draw a horizontal line, you can see we have 3 intersections. Number 1, number 2, and number 3. So that are the 3 solutions. So you can see for the function graph, it's easier to tell how many solutions. And then if tangent of x is 1, so just draw this is 1. Then you can see we have number 1 and number 2. Even though here we have another solution, but because you can see it is out of the range 2 pi. So we don't consider this solution, we have only 2. So what are the 2 solutions? You can go back to the unit circle to find it. But at least you can tell we have 5 solutions for this one. And periodic functions are never one-to-one. Then how can we solve for the equation? We will force the one-to-one by imposing a domain restriction. So let's go back to this one. Even though you can see the tangent function is not one-to-one because it's periodic, but if we restrict the domain just from, for example, from negative pi over 2 to positive pi over 2, or just from 0 to pi, then you can see if just from 0 to pi, then the function will be like this one and that one. Then you can see this is a one-to-one function, because if you try to draw a horizontal line, we have only one intersection each time. So by domain restriction, we can force the periodic function to be just a function, a one-to-one function. And then the next one, you can see this is a sine of x. Sine of x, okay, we know it's not a one-to-one function, but if we only consider the right part, you can see only the right part from negative pi over 2 to pi over 2, it is a one-to-one function. So for the right function, you can see if the domain, we restrict the domain to pi over 2, negative pi over 2 to positive pi over 2, you can see the corresponding range is from negative 1 to 1. So that means the inverse function of the right function, we can find the inverse function of the right function because it is a one-to-one. Then for the inverse function, we have 2 ways to represent it. The first one is arcsine, and the second one is just the sine inverse of x. So they are the same thing. For the test exam, most of the time we use arcsine. So for the inverse function, just remember, for the inverse function, you can see arcsine is sine inverse of, so their inverse function, you can see, okay, for the sine function, if the domain is this one, then the inverse function, that is the range. Similar for the sine function, if this is the range, then for the inverse function, it's the domain. So I make a table here. This is the first general function. This is the general inverse function. So we have to switch the domain and the range. Then similar, you can see for the cosine, this is the domain. For the inverse function, it's the range. Okay. So inverse function is not 1 over sine of x. They are different. Inverse function is just the arcsine. They are the same thing. And then this is a very important part. Remember, for example, the red function and the blue function, they are inverse function. A very important geometric property is that they are symmetric with the y equals to x. Y is equal to x. That means it's like the mirror reflection. Y equal to x is the mirror. So that means if you are given, in the exercise, we have a similar homework. So that means if you are given a function like that one, we know the inverse function is, because this function is 1-to-1. So first, try to draw the y equals to x. Y is equal to x. This is the measure. And then draw the So this is the inverse function. This function is the inverse function of the black one. Similar, you can see this is the measure. If this is one function, then this is another inverse function. So this is cosine, arc cosine. And this is also similar. You can see this function, we have a 2 horizontal asymptote. But still, this is the measure. Okay, so this is the third kind of question. For this, you can see arc cosine is a function, but here, remember, arc cosine is the same as cosine inverse. So that means, what is the value of theta, where theta is an angle, such that, because this is the inverse function, such that this is the x value of the inverse function. So that means this is the y value of the function. So that means, what is the value of theta, such that cosine of theta is 1/2. And remember, the theta must be from 0 to pi. That is because for the arc cosine, the range must be from 0 to pi. And also for the cosine, the domain is from 0 to pi. So we are looking for the value of theta must be from 0 to pi. So for this one, it's just pi over 3. You can, by using the unit circle. All right, pi over 3. That is because remember, this is always 1. So the first one shows you, this triangle shows you, this is a 1/2. This is a 1/2. So the sign of this one is 1/2 divided by 1. So it's 1/2. And it is positive. So that's why we choose this theta, which is 60 degrees, which is pi over 3. We don't use this one because this one is negative. So from 0 to pi, we only use the half part. We have only one solution, that is this one. Okay. Then similar for this one. But sometimes we may have more than one solution. Okay, this is a very good exercise. So you can see that arc cosine of cosine, we cannot just cancel because arc cosine means cosine inverse, but we cannot just cancel cosine inverse cosine and then say the solution is 7 pi over 6 because the range is 0 to pi. That means for our solution, it must be from 0 to pi. This one is now in this range, so we have to choose another one. That is 5 pi over 6. Okay, the second and last kind of question is a little bit difficult sometimes. For this one, okay, first ignore this part, just look at this part. This part, we know the answer is a theta. And then you can see, after we got this answer is theta, so the next question is, what is sine theta? Sine theta is easier to get. So the first question, try to answer the first question, what is theta? For theta, cosine means, okay, suppose this is theta, cosine means this one divided by that one. So we know this is 2, this is x, and because it's a right triangle, so we know this part is this one. And then, so this is theta, cosine. So the next question, what is the sine of theta? Sine of theta, we know this one, and that one. So it's easier to get sine of theta. Just use this number divided by that number. Then we are done. So even though we don't know what is the specific number of theta is, but we know all the 3 numbers. This one, and that one. So we can get the sine of theta, cosine of theta, tangent of theta directly. So the exercise, actually this is a in-class exercise, but because Zoom is not working today, so I just leave this as homework, which is due tomorrow. So for this one, we have, for example, the first question I'm gonna give you, this is the function f of x. So we know the first one, f inverse of x, you can just draw a measure first. That is y is equal to x. Then the function is just the shadow of the measure. So this is f inverse of x. Then what about this part? What about that part? The second question is this one is, even though it's long, but just break it into pieces. This one first, this one second, this one third. This is a little bit tricky. Okay. So if we use this one and that one first and then plus this one, it will be easier. This is okay, this is pretty similar to the triangle. And so for this equation, for the last question, it's a little bit difficult. If you got this one, then you are gonna get extra 5 points. But if you didn't get it, it's okay. You don't have to worry about it. All right, feel free to let me know if you have any questions about the homework or about the MyLab. And also remember the MyLab homework is due today, 11:59 p.m. This is MyLab. we still have 3 students who haven't registered for the MyLab, and about 8 students who haven't finished the homework up to now. So please finish them as soon as possible. And another is remember is quiz 1 this Thursday in class. And quiz 1 is about section 1.3 and section 1.4. All right, thanks for watching, and remember, if you have any questions, just send me an email, or we can make an appointment to talk about the specific question, because sometimes the question you have, all right, let's cut the talk. Just feel free to send me an email. Thank you.